Everyone learns quantum mechanics breaks reality. Particles in two places at once. Random outcomes. True uncertainty at the bottom of the universe. But that's not the whole story. Too many worlds and decoherence. They killed randomness. Brought back pure determinism. The universe runs one rule. The Schrödinger equation. No sudden collapse. No dice roll. Everything that can happen. Does happen. Different outcomes. Different branches. All of them real. So here's the problem. If every possibility happens, there's no might or maybe. No probability. Just certainty in parallel. Yet we test the Born rule 1,000,000 times. It works. Perfectly. Quantum events follow exact probabilities. Wave amplitude squared equals observation chance. Never fails. A deterministic universe. That obeys a probability formula. That's the paradox nobody solved. To crack this open, we can't just stare at quantum mechanics. We need to go deeper. Probability itself has always been broken. Everyone uses it. Few understand it. The math is flawless. Kolmogorov's axioms. Rigorous. Unshakable. But ask what probability actually is. And you get 4 different answers. None of them complete. Let me show you. A simple thought experiment. The Sleeping Beauty problem. Here's the setup. Put Sleeping Beauty to sleep. No memory of the experiment while under. Flip a fair coin. If heads, wake her Monday. Ask a question. Drug her to forget. Wake her Tuesday. Ask again. If tails, wake her Monday only. Ask once. Done. Every time she wakes, you ask the same thing. What's the probability this coin landed tails? She knows all the rules. The coin is fair. 50-50. So what's her answer? Half the scientists say 1/2. The other half say 1/3. Both are right. View 1. Probability is 50%. The coin doesn't care how many times you wake her. Flipping it is independent. No new information changes the coin's result. Tails was always 50%. Still is. View 2. Probability is 1/3. Run 1,000 experiments. 500 heads. 2 wakes each. 1,000 total Monday heads plus Tuesday head sessions. 500 tails. 1 wake each. 500 total tail sessions. 1,500 wakes. 500 are tails. 1/3. If she bets every time she wakes, tails wins 1 in 3. Same experiment. 2 answers. Both logically sound. That's the crack in probability's foundation. Let's go deeper. For schools of thought. Classical probability. The oldest view. Laplace said it best. The universe is deterministic. Everything has a cause. Probability is just ignorance. We can't track every air molecule. Can't measure the exact force on a coin flip. So we invented probability to patch the gap. To a demon with infinite knowledge. Probability doesn't exist. Sounds clean. But there's a fatal flaw. Bertrand's paradox. Imagine a factory makes dice. Edge length between 0 and 1. You know nothing else. What's the chance the edge is less than half? 50%. What's the chance one face has area less than 0.25? 25%. What's the chance the volume is less than 1/8? 12.5%. Same dice. Same ignorance. 3 probabilities. The so-called principle of indifference collapses. Your choice of frame changes the answer. Classical probability pretends to be objective. It's not. Next up. Bayesian probability. Radical honesty. Probability is subjective. It's your confidence. Your belief. 50% doesn't live in the coin. It lives in your head. As you gather evidence, you update. That's Bayes' rule. This works. AI runs on it. Machine learning. Data science. All Bayesian. But it has a cost. If probability is subjective, math stops being universal truth. Your probability and mine could differ. Bayesians patch this with rational agents. A perfectly rational person, given the same information, reaches the same probability. But perfect rationality is a myth. We're defining objective math with an imaginary ideal. Circular. Third. Frequentist probability. Most scientists use this. Probability is the long-run frequency. Flip a coin 1,000,000 times. Heads approaches 50%. At infinity. The frequency is the true probability. Objective. Testable. Grounded in experiment. Except. You can never reach infinity. You always stop at some finite number. Why assume the pattern holds? Worse. Many events happen once. The Big Bang. A supernova. One quantum measurement. No repeats. No frequency. Frequentism fails. Fourth. Physical propensity. Probability is real. Built into the universe. A particle has an intrinsic tendency to decay. That tendency is objective. This fits quantum mechanics beautifully. The Copenhagen interpretation loves it. But nobody can define propensity. You can't measure tendency. Only outcomes. It's a concept invented to explain the data. Not observed. Assumed. 4 interpretations. 4 gaps. Probability has no agreed foundation. Quantum mechanics didn't create the problem. It exposed it. For decades, physicists avoided the issue. Copenhagen made it easy. Just declare the Born rule an axiom. Don't derive it. Don't question it. Probability is fundamental. Accept it and move on. Clean. Practical. But shallow. It never explains what quantum probability is. Why amplitude squared? Why that formula? Worse. Copenhagen says probability only appears when you measure. Before measurement. No probability. After measurement. Collapse. So is probability in the particle? The measurement? The interaction? Nobody knows. Some took it further. Quantum Bayesianism. Forget objective reality. Quantum mechanics doesn't describe the world. It describes your beliefs about the world. Wave function. Your subjective knowledge. Collapse. Updating your belief when you learn something. Probability. Pure subjective confidence. Logical. Disturbing. If quantum probability is just in your head, why does everyone's head agree? Why do nuclear reactors work? Why does quantum computing run on the same rules? Bayesianism can't answer that. Now. Back to many worlds. The theory is beautiful. Deterministic. No collapse. No randomness. But it has one fatal problem. It can't naturally produce the Born rule. Imagine Schrödinger's cat. 2 branches. Amplitude A leads to dead cat. Amplitude B leads to living cat. Born rule says probability of dead is A squared. Probability of living is B squared. But in many worlds, both branches exist. Both are real. Classical logic says 2 outcomes. 50-50. That contradicts experiment. If many worlds can't explain Born, it's not a complete theory. For decades, this was the deal breaker. Then 2 breakthroughs arrived. First, decision theory. Deutsch and Wallace asked a different question. Stop asking what probability is. Ask what a rational agent should believe. Imagine you're betting on quantum outcomes. Every result happens. Universe splits. You experience one branch. What's your optimal strategy? They proved. Using only 2 rational axioms. Zero-sum symmetry and reward scaling. You must act as if Born rule probabilities are true. No extra assumptions. Just logic. Translation. Probability isn't in the universe. It's in how rational minds navigate a branching universe. You follow Born rule. Not because nature is random, but because that's the only rational way to make decisions. Second, quantum symmetry. Zurek and Carroll went deeper. Quantum systems have a strange feature. Know everything about the whole. Know nothing about the parts. In classical physics, if you know the system, you know each piece. Not in quantum mechanics. Entanglement makes the whole fundamental. Parts don't have independent properties. When you split the universe into system, environment, and observer, even with total information, you lose local knowledge. Not because you're limited. Because the structure of reality forces ignorance. That forced ignorance creates asymmetry between branches. And that asymmetry is exactly the Born rule weight. Amplitude squared. Probability emerges. Not from chance, but from the observer's inevitable information loss. So here's the answer. In a deterministic universe where everything happens, what is probability? Probability is self-location uncertainty. The old question was, how likely is this outcome? The real question is, which branch am I in? The universe isn't rolling dice. It's splitting. Every version of you exists. One you wins the lottery. One you doesn't. One you makes every right choice. One you makes every wrong one. All real. All happening. You feel probability. Because you can't see the other branches. You can only experience one thread. Born rule weights. Those are branch weights. The measure of existence across the multiverse. Your best guess at where you are. This solves the Laplace demon paradox. From outside the universe, a God sees everything. No uncertainty. Pure determinism. From inside, tangled with the system, you can't be omniscient. You're finite. Locked in one branch. So you experience probability. Not because the universe is random. Because you're trapped in a slice of it. Probability is how limited beings understand a determined cosmos. One last thing. If every possibility happens, does effort matter? Yes. There's a branch where you succeed by luck. A branch where you fail despite trying. But Born rule weights don't lie. The highest probability branches. The ones with the most measure. Are the ones where your choices align with better outcomes. Every decision you make shifts which high-weight branch you land in. Low probability disasters exist, but you'll almost never experience them. The universe wrote every ending, but your choices decide which ending you live.